So in this video, we're going to focus on taking our conceptual sketch and design and the measurements that we've taken and loading them into Fusion 360 and also figuring out any related measurements and computations that we need to be able to make our parameterized functional 3D model in Fusion 360. So I'm going to go down here and under modify and change parameters and add some user parameters. So let's see what we have. For the cup, we have the base diameter. So we're going to say diameter cup base. And what was that? 58.80. And for some reason, there's this pesky menu. Okay, there it's gone. And then we also have the top diameter, 91.57. And then the height, 146.23. And then, as I said in the design consideration phase, we need to know the depth of the holder. So I'm going to say depth holder, and tentatively, we're going to go for 1/3 of height of cup. And like I said there, this is just the first iteration, and we'll see where we go from there. What else do we have? The handle. So we've got the diameter of the handle, and we're going to call this the top of the handle, and that'll be 66.85. There's also going to be the diameter of the handle at the base. So let's go for about 2 inches, which is about 50 millimeters, and let's just see where we get from there. This does need to support a fair bit of weight, so having this thick isn't really a bad thing. What else? We've got the height of the handle base, and we said that that should actually be the same thing as the height of the cup. So we're going to set it equal to that. So we've got the depth of the holders. So one thing we need to know is when we think about the base of the holder, we need a wall thickness basically. So I'm going to add a wall thickness, and based on my experience, I have kind of two go-to wall thicknesses. For non-strength bearing parts, ones that are more cosmetic or ones that only carry light loads, 2 millimeters is my go-to minimum wall thickness, and that's kind of what you'll see if you search around for, say, 3D print minimum wall thickness. 2 millimeters is pretty typical. You can go smaller, depending on what you're doing. You know, that can work. But for functional prints, I'd probably never go below 2. But especially with PLA, that does tend to give a little bit of flex, and it's just not as rigid as if you do 3 millimeters. And for this part, I want strength, I want rigidity. So I'm going to say thickness, or how should I do this? Width wall, 3 millimeters. Another thing that I'm going to try and predefine is a parameter I'm going to call smooth. And this is, I'm going to just go based on experience and say I'd like this to be 2 millimeters. It might need to be 1.5, might need to be 3. We're going to have to see how exactly this looks. What smooth is anytime I do a chamfer or a fillet, I'm going to try and set it to this. And this gives me kind of a central way to, actually for all these parameters, the whole point of setting these here is if I realize, let's say I mismeasured something, well, I can take that measurement again, update it here, and the whole part is going to update for me. Likewise, with some of these items that I'm kind of going by experience and intuition, if I get into the design phase, if I get into the CAD and I realize this is not looking right, then I can just edit it here and see what the result is. So I think that there probably should be a little bit more. So at the top of the handle, we saw how it's coming out at an angle, and there's a top diameter, but there needs to be some thickness to it. Remember we want to honor this minimum wall thickness. So I'm going to say height handle top, and we're gonna call that. I'm just gonna actually put in width of wall. Actually, I'm gonna go a little bit further. I'm just gonna call that 5 millimeters. 5 millimeters is like the the diameter of a pencil eraser, and that's pretty good. That's some good heft to it. I don't want the top of the handle to feel flimsy or weak. I don't want it to feel like it's gonna shear off with the weight of the cups. So from here, I do think that there's one more thing. So for the final parameter that I like to define here, you might recall from the design consideration phase, we have these angled glasses. They've got a base diameter, which is less than the top diameter, and then a height. And we're going to assume that the angle that they come out at, that angularity, that's all linear. It's not curved. It's simple. But I really need that angle because that's how I'm going to be working on the depth of these cup holders. So I want to compute that angle here in the parameters section. And then that angle can also be dynamically computed from the other parameters we have here: height of the cup, diameter cup base, diameter cup top. So to visualize this, I'm going to get out of the parameters, and I'm going to create kind of a throwaway sketch. I'm not going to be using this as part of the product, but it'll help visualize what's going on. So let's say we have this cup. So we've got diameter of cup base. We've got height of the cup. And we're going to fit so we can see what's going on. And we're going to say diameter of cup top divided by 2. So just the radius. And then this is what's going on. And now I could use the measure tool and actually compute the angle right now, but I want this to be done dynamically. I'm not going to do this and then copy paste it because I want it to be such that if I alter the diameter or the height, if I have to go and remeasure this, the angles can update automatically for me. So what I want to do is use trigonometry. So the way I'm going to visualize this is we're going to start at the top left corner, come down, and I'm going to let it extend, and you'll see right there in the middle there's that green right angle icon. So that means that I've got my right triangle going, and here it is. So if we think about it, what is this distance right here? That is diameter of the top over 2 minus diameter of the base over 2. So just top radius minus the bottom radius is this little extra. So that's what that is. And then this, basically this is h, this is height. So if this is my right triangle, I'd like to know what this angle is. Specifically, let me show it right here. I want to know what this angle is. So if I know what this angle is, I can handle the fact that the cup is angled when I'm creating the cup holders. So what is this? If this angle right here is theta, this is opposite, which is h, and this is adjacent, which is this value. I'm just going to copy and paste this. Diameter cup top over 2 minus diameter cup base over 2. And if you remember from trigonometry, a tangent of theta, this one right here, is equal to opposite over adjacent. So to get theta, we do the arctangent of opposite over adjacent. And I'm just going to click finish sketch, and then I'm just going to actually just delete that from the timeline because I got what I wanted. I'm going to go to change parameters. I'm going to add angle and glass, just angle glass. I think that's enough. And then for units, I'm going to change that to degrees. And now I need to put in my expression, which will be arctan opposite, which is height cup over, and I'm just going to paste that in the adjacent value. And we get the answer 83.6. And that's exactly what we had measured. And this annoying little tooltip here showed up. So let me just hit OK, get rid of that, and go back to parameters. So you can see the formula shown right here. There, now we can see the whole thing. Arctan of height cup over this top radius minus the bottom radius, and we get 83.6. I'm just going to go ahead and save. When you use Fusion 360 and you save, every time you save, it's a new version. Fusion 360 supports versioning. I honestly just use the default value. I'm not working collaboratively. If I was, this would be a lot more important, but I'm not. So, and let's take a look at my settings. I think that I had these edited from some previous work. I want a layout grid would be nice. I think that's probably enough for now, and if I need anything else, I'll add it later. So what I like to do, in Fusion 360, you have the concept of like the whole project, and then under the project, you can have components. And I like to use components not strictly for different parts or different literally components of the same part, but also for different variants of the same part that are logically connected. So instead of having like one project for, let's say, the shower organizers that you can see on my profile, instead of having one project for the cylindrical organizers, one for the basket, one for the double cylindrical, I just have one project for shower organizers, and then I have multiple components, one for each organizer. And I like to, even if I'm not expecting to have multiple variants or anything like that, I always just like to start with a new component. Just because if you don't, and maybe there's something with Fusion 360 I'm missing, it's difficult to, and just very inelegant to add your current work into a component and actually have that kind of nicely reflected on the timeline. So we're just going to call this cup holder. It's the same name as the project I have here. And we're just going to hit OK. So let's get started. So what I'm thinking is we're going to start with a sketch. I really am heavy on sketches in Fusion. And let's see, I seem to be, can I get a grid? Sketch grid. That was missing. Okay. So we're going to start with how are we going to do this? Because let me look at my parameters list. If you think about it, we have the diameter of the handle and the diameter of the cup at the base and also at the top. One thing that I need to know is what is the diameter of the cup at the point of the top of the base. So actually, let me go back and make a dummy sketch just right now. So what we're going to do is we're going to say diameter cup base. We're going to go up by height of the cup. We're going to come out by diameter cup top over 2, so the radius. And there's our cup. And then I'm going to start back down here at the base, the center, and I'm going to go up by height of let's see, no, I called it depth of the holder, which is currently 1/3 of the height of the cup. And I'm going to come out perpendicular. So this distance right here is actually the radius of the overall, I should say, radius of the cup holder that we're trying to fit. But what is this radius? How do I know what this is? So again, coming back to the trigonometry. So I know what this, let's see, let me actually show it here. I know what this angle is. I already have that measurement, 83.6, and I know how it's calculated dynamically. What I need to do is I need to figure out how I can compute this. In other words, right down here, how do I get that little bit? Let me zoom in. So I know what this height is. That's the depth of the holder. And what else do I know? I know what this angle right here is. That's that computed 83.6. And then the question is, how do I get what this little distance is? So this right here, I'll go to the measure tool. From this point to this point, it looks like it's 5.462. How do I know that? Well, that's the radius of the base of the cup. In other words, this diameter divided by 2. Just move it out of the way. Plus this little bit. If I know this angle and I know this height, I want to get this little bit down here. So it looks like we're using the tangent again. So tangent of this angle is equal to this opposite side, which is that depth of the cup holder, over the adjacent. So I'm going to move over to a little notepad. I think it'll be easier to figure this out. We know that tangent of the angle is equal to opposite over adjacent. In other words, tangent of the angle is equal to depth of, let's see, it's called the cup holder. I don't remember exactly what I called the parameter. Over, I'm just going to call it x. We want to know what x is. So if you multiply both sides by x, then you get x times tangent of the angle is depth of the cup holder. And finally, if you divide both sides by tangent of the angle, then you get x, which is that little sliver that we want to know, is depth of the cup holder over tangent of, if I can spell right, cup holder over tangent of the angle. And then finally, what we're actually interested in is the overall, in this case, its radius of the cup holder is equal to its x plus radius of the cup base. Or, put another way, diameter, because we've been working with diameters this whole time, diameter of the cup holder, just multiply everything by 2. So it's 2 times x plus diameter of the cup base, because 2 times the radius is the diameter. Or diameter of the cup holder is equal to diameter cup base plus 2 times depth of the cup holder over tangent of the angle. I'm going to copy this, and then we're going to come back over to Fusion. So first, before I put in the formula, let's see what we expect to get out of it. This little bit is 5.462, but what's actually interesting is from here over to here, 34.862. That's what we expect to get for the radius. So diameter of, let me hit cancel. I want to get rid of this little pop-up. Okay. I want to keep the naming consistent, so I have depth of holder, so I'm going to say diameter of holder, and that is equal to what? I'm pasting this in. So it is diameter of the cup, diameter of the cup base plus 2 times depth of holder divided by tangent of the angle of the glass. Let's see if it'll take. Nope. Diameter. I have to spell it right. So I got 69.723. So that's about 70. If you divide that by 2, you get about 35. What was our value here? Basically 35. This looks right. So we have what we need. And this sketch, again, was just kind of a dummy here to figure out the trigonometry. So I'm going to copy everything and delete it. So at this point, we've finished loading in all of our parameters and figuring out, or at least our first iteration of derivative computations from those parameters, and loading them all into our Fusion 360 project. So the next step, and this is what we'll cover in the next video, is to start making a first pass at all of the geometry in the 3D model. So look out for the next video there.